Hello everyone, welcome back to another session. In this session, we are going to solve only exercises from the book. Previously, we studied the rules of differentiation, all the necessary rules being studied in the previous session. Now we are going to use them, we are going to apply them to solve these exercises from the book. There are very good exercises among them. Let's begin. Question 1. In exercises 1 to 11, find the derivative of the given function. All right. The first function given, y equal to 8. What's the derivative of constant? It's equal to 0. The question said y, then we should say y prime. This is the derivative. So derivative of numbers is always 0. Question 1 done. Question 2. We have x with power. It's in term of fx, and the answer is like this. F prime x equal to power goes to the front, power minus 1. 6x power 5. This is the answer. Question 3. Fx equal to 1 over x power 7. Most of you, when you see this, you want to directly use the quotient rule, the fraction rule. The fraction rule makes this long, and there is a high chance of making a mistake. There is an idea, okay? It's not rule, it's idea. When you have fractions like this, we can rewrite fx is equal to 1 over x power 7. We can rewrite this. Rewrite, it's not derivative. It's only rewriting to make this look easier, then we do the derivative. We can rewrite as fx is equal to x power negative 7. Any x that has power, when it's down, when we bring it back up, the power becomes negative. So x power 7 down is the same as x power negative 7. Now finding the derivative of this is the same as this. Power goes to the front, power minus 1. Then this is f prime of x is negative 7 x power negative 8 power minus 1. You have calculator. Never let these mistakes happen. You have calculator. Write in your calculator negative 7 minus 1. You see negative 8. Now, if we want to write the answer in the simplest form, negative powers are not simple. Any term that has a negative power, it should go down as well. Final answer is negative 7 over x power 8. This is the answer. Question 3 done. Question 4. Same idea. We can rewrite every root problem as power, then use the power rule, which is the easiest rule, to find derivative. Always refer back to this. Square root of x square root of x, square root. There is no power means 1. There is no index for the root means 2. This square root of x, we can always write it as x power 1 over 2. So the power of the x inside the rule goes up. The power of the root goes down. Now, if I want to find derivative, this derivative is easy. It's 1 over 2 root x. But this one is not very easy. So it's better to rewrite as x power 1 over 5. X power 1 over 5. To find the derivative, power goes to the front, power minus 1. To find the derivative, f prime of x is equal to power goes to the front, 1 over 5, x power minus 1. 1 over 5 minus 1. You can write this. Later do it. Anything, any fraction you want to add or subtract to 1, And instead of the 1, I write, let's change the color. And instead of 1, I can write 5 over 5. Now, 1 minus 5 is negative 4 over 5. So the answer is 1 over 5, x negative 4 over 5. Since x has a negative power, it should go down. This 5 is already down, so the answer is 1 over 5. X power negative 4 over 5 becomes x power 4 over 5. The power is positive. Fraction powers could be root again. So 1 over 5. The root is power 5. And the x inside the root is power 4. So the final answer is from here to here. The final answer is 1 over 5, fifth root of x power 4. Question 5. 3x minus 1. Derivative of 3x is 3. Derivative of 1 is 0. So the answer is f prime of x is 3. Question 6. We have some terms added, subtracted together. So we do each one separately. F prime of x is equal to negative 4x. For this part, it's negative 4x plus 3. Minus 6 becomes 0. Now, question 6 done. Let's do some more questions. Here, question 7. 2x power 3 minus x power 2 plus 3x. You're supposed to be able to do this by now. And I'm sure you can do it. F prime of x, this is question 7, is equal to 2x power 3 is 6x power 2, power minus 1. X power 2 is minus 2x. 3x is just 3. So this is the derivative. Question 8. It's a sign question. What makes question 8 different is theta. There is no x in question 8. Theta, no problem. We just use the rules normally. Consider the theta as x. Now, question 8. Derivative of sine theta. If there is a number before a function, this number doesn't affect the derivative. Pi over 2 is a number. Pi is a number. Pi is not a variable. But theta is a variable. X is variable. Y is variable. Derivative of sine is cosine. Cosine theta. Finish. Minus, this minus as it is. Derivative of cosine is negative sine theta. Now if I simplify this, it will be pi over 2 cosine theta minus minus is plus sine theta. This is the answer. Now question 9. Question 9. X power 2 minus 1 over 2 cosine. Let's do it. X power 2, question 9. X power 2 becomes 2x. F prime of x is equal to x power 2 is 2x. Minus. If there is a number before any function, the number doesn't affect. Write it as it is, 1 over 2. Derivative of cosine is negative sine x. For such questions, when there is only x inside the sine or cosine, we don't say times the derivative of inside. Why? Because derivative of inside is just 1, and if we multiply anything by 1, nothing happens. This is why many students think like it's always like this. No, if the derivative of inside is not 1, we should mention it, we should write it, and we should simplify it. Here we don't have simplification, except 2x. Negative times negative is positive. 1 over 2 sine x. If I multiply 1 over 2 by sine, it will go only before the sine. nothing can affect the angle. This x inside the sign is locked. If I multiply, if I divide, if I do anything to this sign, the x will not change. It stays as x. Question 10, 1 over x minus 3 sine. 1 over x is, there are two ways to do it. One way is to memorize it. One way is like this. 1 over x is like x power negative 1. It will be negative 1 x power negative 2. Or you can memorize it as negative 1 over x power 2. 1 over x becomes negative 1 over x power 2. Minus 3 stays the same. Sine x becomes cosine x. Okay? The negative only available with cosine. When you find derivative of cosine, result is negative sine. But derivative of sine is directly cosine. Then this minus stays the same. This is the answer. Question 11. Question 11. 5 over 2x power 3 plus 2 cosine x. Okay. Let's do this part first. 5 over 2x power 3. It will be like 2 power 3 x power 3. That's a power property. If there is a bracket with power, how many terms are inside? Between them is times. If between them is plus or minus, we cannot distribute the power. But between the 2 and the x is times, then the 3 equally goes to the 2, goes to the x, like this. Now, if I want to find the derivative, I need to use either the quotient rule, denominator power 2, denominator times derivative of numerator minus numerator times derivative of denominator, which is a very long fraction. There is a very high chance of making a mistake. Let's rewrite this is better. So far it's rewrite. It's not derivative. This common mistake happens very often. Students, when they rewrite a function, they will have a feeling like they did the derivative. Make sure when you rewrite, rewrite, do not forget. Again, I need to rewrite. 2 power 3 is 8, so 5 over 8. It has no problem, it's constant. X power 3 goes up, becomes x power negative 3. This step is also rewrite. Now it's derivative. F prime of x equal to, power goes to the front. The 5 over 8 will not affect anything, stays the same, times negative 3, which is the power that goes to the front. X power negative 4. For negative numbers, when we say minus 1, it becomes one step less. Minus 3 becomes minus 4. These two will be multiplied. The answer is negative 15 over 8. The 8 is already down. X power 4 should go down as well. Negative 4 becomes positive 4 down. Now the derivative of the first part, done. Plus, derivative of 2 cosine x is the two the same. Cosine becomes minus sine x. Now, positive 2 times negative cosine becomes minus 2 sine x. Now, this is the answer of question 11. If you have any question about these, you can comment below. I'll get to answer you accordingly. Let's do some more exercises. But the rules are rules. You should memorize them. And the ideas are important. It makes the way of using the rules easier and saving time. Here in questions 16 to 25, find the derivative. This question is one of the most important questions in this set. Let's see this. X power 2 minus 5 minus 3x power negative 2. Okay. If I want to find the derivative, x power 2 becomes 2x. 5 becomes 0 in the derivative. Negative 3x, okay, it has power. Power goes to the front. Negative 3 times negative 2 is positive 6. Power minus 1, negative 2 minus 1 is negative 3. Now, it's not simplest because there is a negative power. I can rewrite as 2x plus 6 over x power positive 3. The x had a negative power, but when it goes down, the negative power becomes positive. Like this. This is the answer of question 16. Question 17. T squared is simple. F prime of t squared becomes 2t. That's obvious. But negative 4 over t power 3, we either need to use the fraction rule or the idea. This time I want to use the rule because many students like to use the rule rather than ideas. Or ideas you can forget, but rules are different. Rules, you study it so hard, you don't forget the rule. But ideas you can forget, or you can mix, or you're not sure. Let's use the rule. The rule always works, but the steps are a little bit more. Let's use the rule for 4 over t power 3. Using the rule, denominator squared, t power 3 squared. I don't simplify, I only write. Until I see the rule, everything applied, then I start simplifying. Denominator is squared, that's it. I write the denominator again. T power 3 times derivative of numerator, derivative of 4 is 0. This entire part is gone. T power 3 times 0 is gone. Minus, this time I write second, which is 4, times the derivative of down, which is 3t squared. Now, I have negative 4 times 3t squared, which is negative 12t squared. And this will be t power 6. If a term has two different powers, we should multiply the two powers. So down will be t power 6. Let's complete the simplification here so you can see all the steps together. T power 3 power 2 is t power 6. And up, this part became 0. This is negative 4 times 3. That is negative 12. And t is power 2, t squared. Since next to this t, there is no any plus or minus. It's times. There is no any other term. I can simplify this. T power 2 will be cancelled with 2 from this power. So what's remaining is t power 4. Final answer is negative 12 over t power 4. This is the final answer in the simplest form. For the part of 4t cube. When you are solving questions, don't lose track. Look back to the question before you leave. We had two parts in the function. This part, 4 over t cubed, is here. We did the derivative. We got negative 12 over t power 4. And t squared, it simply became 2t. So this answer, there is a minus, then this answer. Minus minus becomes plus 12 over t power 4. So final answer of this question 17 is 2t plus 12 over t power 4. So simplifying is very important, and looking back to the question. Don't lose track. When you solve a question, don't lose track. Don't give up. Look back. The question is two pieces. It's minus between them. When I do the derivative will be two pieces. minus between them. One piece, t squared becomes 2t, that's obvious. The other one, we need to do it. Then doing it, we either use the idea of bringing back this up to have a negative power, or using the quotient rule. Both ways work. There is no problem between them. It's all about you. The way you study, the way you solve, do you like to use the rule, or you want to use the idea and do everything quick? It's all about you. Some of you might think using the rule is easy. It might have a lot of steps, but it's manageable. Each step follows another. But there's also some students who like to use the idea. If you want to use the idea, this will be, the rewrite of this will be 4 t power negative 3. Then finding the derivative makes it negative 12 t power 4 down. So it will be the same answer. Question 18. Pay attention to this question. There is a way of doing such questions. There is one denominator for 3 terms. We can separate this to 3 different fractions, then do the derivative of each one. That will not take any time. All right? But if you want to do this using the quotient rule, denominator power 2, denominator times the derivative of numerator, there will be a lot of steps. There will be a lot of plus, minus, x's with powers, and there will be x power 4 down, and it will be hard to simplify. Look at this. For question 18, for questions like this, always use this idea. Question 18. This is a rewrite step. I will write this denominator to all of them. All right? If we have one single term as denominator, we can give this term to all the other terms in the numerator. So it will be like x power 3 over x power 2. And of course, you can simplify this. Minus 3x power 2 over x power 2 plus 4 over x power 2. Okay? Now there is simplification. Here, x power 3, x power 2, what's remaining is just x. Minus x power 2's cancel out, what's remaining is only negative 3. Plus 4 over x power 2. This is the only part that has no any simplification. Now if I want to find the derivative of x is 1. Derivative of 3 is 0. What's remaining is this. Let's do the derivative of this. Using the idea, if I want to rewrite this, it will look like 4x power negative 2. Then doing the derivative of this is negative 8x negative 3. So the answer is negative 8 over x power 3. Derivative of this part is negative 8 over x power 3. Derivative of x is 1. Derivative of 3 is 0. So it's just 1 plus. Plus minus becomes minus. So final answer is 1 minus 8 over x power 3. This is the final answer. Once this question came in the exam, and the choices were like with one denominator. To rewrite this one as something over x power 3, you can rewrite this as x power 3 minus 8 over x power 3. This is also correct. Now let's do another question. So as I told you, this question is a good question. Here, same ideas keeps repeating. For this question, we can use the product rule, or you can multiply the x by inside, simplify, then do the derivative. Both ways work. But I always recommend simplifying, then doing the derivative. It makes the derivative, the steps of the derivative easier. Now, for question 19, always mention that if you are rewriting, then also show that if you are doing the derivative actually. it's still fx, it's not f prime because I'm not doing derivative. I only want to multiply the x by inside, then find the derivative. X times x power 2 becomes x power 3 plus x times 1 is x. Look, finding the derivative of this is way easier than using product rule on these two terms. Derivative of x power 3 is 3x power 2. Derivative of x is 1. Then this is the derivative. Question 20, there are roots. Roots will be easy if we write them as powers because derivative of powers are the easiest. Question 20. This is rewriting. And instead of square root x, we can directly do the derivative of this. We don't need to rewrite this. The derivative of it is directly 1 over 2 root x. But for this one, we are not sure. We don't have a direct rule to do it. Then it's better to rewrite it. This is a rewriting step. We don't forget, after we do the derivative, there is a minus after this minus. Now let's find derivative of this part and write the answer here to complete the derivative of f in question 20. Rewrite 6 cubic root of x is the same as 6 x power, what's the power of x inside the root is 1. So x power 1 over 3. Now derivative power goes to the front. 6 times 1 over 3 x power minus 1. 1 over 3 minus 1 is like, instead of the 1, I can write 3 over 3. It is 1 minus 3 is negative 2 over 3. Since it has a negative power, should go down. And there is simplifying between the 6 and 3. The answer will be 2 over x power 2 over 3. Fraction powers, just like this, could be wrote as root. Then the final answer of this part is 2 over, the upper number is the power of x, the lower number is the power of the root. So the answer is 6 divided 3 is 2. The answer is 2 over square root of x squared. We had half of the answer. The other half is this. So we just write it here. 2 over square root x squared, cubic root. The upper number is the power of x. The lower number is the power of the root. So this root should be cubic. So it is cubic root of x squared. You might wonder if power 2 can cancel the root. Power 2 can cancel square root. Power 3 can cancel cubic root. Okay? Power 2 cannot cancel cubic root. Power 4 can cancel quadric root. Okay? It's all relative. Now the answer of question 20 is 1 over 2 square root x minus 2 over cubic root of x power 2. Question 21 has the same idea as this part. Power goes to the front, power minus 1. Then simplify. Sometimes in the exam, the answer, the choices are also given as the power form. Then you don't need to do much simplification. Here, question 22, it is product rule. If I multiply square root x by inside, it will not look any easier. Then it's better just go with the product rule. First times derivative of second plus second times derivative of first. Question 22, I directly do the derivative, then I'm mentioning that. First times derivative of second. First is x power 2 plus 4. Derivative of square root x is 1 over 2 square root x. What I did, I just did first times derivative of second plus second square root x times derivative of first. Since first is a bracket, but because the bracket has no power, we don't use the bracket rule. We just do it normally. Derivative of x power 2 is 2x. Derivative of 4 is 0. And this is the answer. When you multiply a fraction by a term, we only multiplied with the numerator. So the final answer is x squared plus 4 over 2 square root x plus 2x square root x. Then this is the derivative. If I want to make these, this is the derivative, finished. But let's say in the multiple choices you don't see this. What do? The denominator of this part is 1. We multiply up and down by this. 2 square root x. Then when we multiply, 2 times 2 is 4. Between these three terms is not plus or minus to multiply by all. We multiply it once. 2 times 2 is 4. Square root x times square root x is just x. The square roots will be cancelled. Then x times x is x squared. Use calculator. What is square root 2 times square root 2? The result is 2. It means when you multiply same terms under square root by each other, only the square root will be cancelled. So if I multiply square root x by square root x, the result is just x. If there is another x next to it, could be multiplied. Then let's simplify this one more step. The denominator is 2 square root x for both. This one already has this denominator. This is why we don't multiply. 2 times 2 is 4. Let's write the x squared plus 4 as it has no problem. Plus 2 times 2 is 4. Square root x times square root x, the square root will be cancelled. It will be like x. And there is another x to be multiplied, x power 2. The final answer is 5x power 2 plus 8 over 2a, 2 square root x. The 2 will be cancelled as well. So 5x power 2 plus 4 over square root x. Question 23. We have x power 3. We have cosine. Between them is times. Then we use the times rule, the product rule. Directly f prime. First times derivative of second. What's the derivative of cosine? Negative sine x. In multiplication, because multiplication looks like plus, in multiplication for the derivatives we write plus. In division or fraction, division looks like minus. In the rule it has minus between the two parts. Here, first times derivative of second plus second, which is cosine x, times derivative of first. Derivative of x power 3 is 3x power 2. This is the answer. Question 24. We can use the product rule to take this up, or we can use the quotient rule. Let's use the quotient rule. A big fraction. Denominator power 2. Denominator power 2. Denominator, write it again. Times derivative of numerator. Derivative of x is 1. Since it's division, I'll write minus between the two pieces. This time I write the numerator as it is, times derivative of denominator. Derivative of denominator, derivative of the square root is 1 over 2 square root x. Derivative of 1 is 0, no need to write. Then this is the answer. 1 times anything stays the same. Square root x minus 1 minus x over 2 square root x all power 2 Of course, this is not the simplest form. We can simplify this more. This is one way. Another way is to take the denominator all up and give it the negative power. This is a rewrite step. Square root x minus 1 power negative 1. Because this part, square root x minus 1, down, it has no power, means it's power 1. Down, it's power 1. When we send it up, it becomes power negative 1. Now here, since the bracket has negative power, or if the bracket has any power, not 1, I cannot multiply the x by inside. I'll use the product rule for this. First times derivative of second. Derivative of second is like power goes to the front, bracket as it is, power minus 1, times the derivative of inside. Derivative of inside is 1 over 2 square root x. Alright? Plus, its product rule should be plus. Second, which is square root x minus 1 power negative 1 times the derivative of first, which is just 1. I got this. There is simplification. This one is already fraction. This one has a negative power, it should go down as well. And the x has a positive power. It has no power, means positive. It will go up, the x comes here. So it is x times negative 1 is negative x over this thing, power 2. It went down. This 2 square root x is also down. Between them is times, this is why it stays as times down. Plus, this has a negative power, should go down as well. There is nothing means 1, so 1 over square root x minus 1. It has no power, means power 1 as well. So the derivative of question 24 could be also written like this. Both of them are correct, and both of them could be simplified more. Now we can simplify this more. We can expand the brackets, or we can multiply this side by a term to have the same denominators. Both ways work. We don't simplify like this, too advanced, only if the choices are like this. The last question for this session is sine x over x power 2. This is an obvious division. The only way of doing this is, not the only way, but the best way is to use the division rule. Now, denominator power 2, it's x power 2, power 2. Write the denominator again, x power 2, times the derivative of numerator. Derivative of sine is cosine, minus, this time we write sine, times the derivative of down. Derivative of down is 2x. 2x, no negative. Simplifying, it will be x power 2 cosine x minus 2x sine x over x power 4. X power 4 can cancel x power 2? No, because the term that contains the x power 2 is next to minus. But we can take x as common factor. From here we can take x, from here we can take x. The denominator becomes x power 3. So if we take 1x from here, 1x from here, it will be x cosine x minus 2 sine x over x power 3. This is the final answer for question 25. This is the end of this session. Thank you so much for watching. Stay tuned to see the rest of the book.